Hi guys, so this is Professor Innocentes, and I'm providing this recorded lecture for those who were not able to be in class in 1 or 2 days. And as you know, I'm teaching MAT 240, and you may be either in the first section, which is 10654, or you can be in my second section, which is 10659. And I'm teaching these two sections on Tuesdays, starting with the first one early in the morning, and then the second section, which is 10659. And we covered almost similar things starting from the first week up to now. So if you are taking my second section or the first section, you should not worry about what I'm going to explain. I'm going to use just one section to explain what we have already covered. So if you can go to the course menu and click on the table of contents, you will see that we have covered up to week 8, where we cover the continuous random variables. And week 7 was our midterm exam week. So if you go to week 1, and if you can click, you can see that we have notes posted, and these are data literacy notes. In fact, this one was covered on the first day of our class meeting, and let me open it to see what we discussed. I will say this topic was really important, and it explains different types of data or characteristics of data. It is very important to understand different types of data, which are very important. What am I opening? So this one, sorry about that. So I'll go through these PowerPoints very quickly to show what we learned during our first week and how important is it for us to understand different types of or different characteristics of data. So the first thing that we looked at was to understand what is statistics, and we defined statistics as having data and then getting some techniques or procedures to analyze data, where we can get some information from the data, and that information will help us to make decision. So the definition says statistics is a pool of techniques or procedures that can be used to produce a meaningful information out of raw data or out of data, with an objective of providing evidence for decision making. So what we need, or what we are looking for here, is the evidence-based decision making, and our evidence can be obtained from the data. So it is very important to have data and then identify appropriate techniques or procedures that can be used to analyze data that we have, so that we can get information, and that information, as we said, will help us to make a decision. So you can see it is very important to start having data. Data is the most important here. If you don't have data, then there is nothing you can do. You cannot analyze data that you don't have. You should have data. And therefore, we need to understand data. Look at different types or characteristics of data is very important. So we started by looking at the definition of data. And so the question was, what is data? And we saw that data are the facts collected for analysis or for references. So facts can be collected for the analysis now, or we can keep them for the future analysis. And we looked at different types of data. So we saw that data can be any information. For instance, we can look at the sales, revenue, profits, population, and so forth. So we looked at different sources of data. And we saw that we have two types of data: primary data and secondary data. And we saw that primary data is the data which is collected or observed directly from the source. And normally it is the data which is not processed. And we can obtain primary data through surveys, observations, and experiments. And then secondary data is the data which is collected and is already collected, organized. And so all we have to do is to look for that data from different sources. So we can find secondary data from the internet, website, organization records, and so forth. So we'll be talking about data distribution or data set. And so what is data distribution? So if we have data set, then we can try to find how that data is distributed. We can say our data is distributed according to, let's say we can say our data is distributed according to gender, according to income, according to, that's what we call data distribution. So we can organize data in many ways. One is tabular form, where data are organized and arranged in a table with rows and columns. And also data can be arranged in ascending or descending order. We can have data in a pivot table and so forth. So data normally, when it's collected, or I'll say primary data, is not organized. But secondary data is actually organized in a table or in a certain form. So we have our data set, which is hypothetical here, to show what we can normally see in Excel. And so here you can see a number of individuals, and this data is organized according to, that's what I was talking about, the data distribution. Data distribution. So here we can see our data is distributed according to, here it is organized according to age. And so that's our data distribution. Or this data is organized in terms of gender. So it is distributed according to gender. It is also distributed according to years of education. Our data is distributed according to the years of experience as well as salary. So here we have what we call variables or fields. And then for these variables or fields, we have observations. So if we take somebody like Sean, for instance, we can see that Sean is 34 years, and this person is male, having 4 years of education and 5 years of experience, and the salary is $65,000. So those are the observations we have made for this particular individual. So as I was explaining here, we have variables and also we have observations. And we have explanations about variables or attributes and also the observations from this hypothetical table. Then we started looking at characteristics of data. And we know that the main characteristics of data could be numerical or non-numerical. And numerical data is the data that has numerals, and non-numerical data is a type of data which has no numerals, or it can have numerals but they can be in category. So numerical data, sometimes we call it quantitative data, has numerals, like we have 0, 1, 2, 3, 4, and these are integers, but also they can have decimal points, but still they are numerals. So we can have 0.23 and so forth, but they are numerical data because they have only numerals. Now, non-numerical data can be qualitative or categorical. So let's say we may have data which is expressed in terms of words, letters, and categories. So example that we have here are gender, where we can have male or female, and then we have states, and you can mention the names of the states or countries, opinions, or even A, B, C. So that's what we call non-numerical data. We don't have numerals. Now, categorical data may have values, but they are not actually numerals, but they are categories. So in this case, for instance, you can see we have the first category, the second one, and the third one. The first category contains values from 1 to 10, so we call this first category. We can also have from 10 to 20, that's the second one, and we can actually call this baskets, and each of this category will have some values from 1 to 10, and when they are in categories, they are no longer numerical because we are counting the categories or the baskets. So we can look at the category of people. In terms of gender, we have male or female, or we can have same categories as we have seen here. So now let's look at the numerical data and see a number of characteristics of the numerical data. The first characteristic is your numerical data can be discrete or can also be continuous. So discrete data is a data which we can say has integers. For instance, we have 0, 1, 2, 3, 4. They are discrete. We don't have decimal points here. So the way we analyze this data is different from the way we can analyze continuous data, and we're going to see that as we're going to move with other topics. So discrete kind of data is when we are looking at the whole numbers. For instance, you cannot have let's say decimal values for the number of children or number of cars, number of houses, and so forth. They are discrete. So either you don't have a child, which is 0, or you may have one child or a number of children, but we cannot have 1 children and a half. We cannot explain that because it has to be discrete value. So continuous values are data that has infinite number of possible values or decimal points. For instance, we have 0 point, or you have decimal points. These are the data, this type of data which allows decimal values. For instance, when you are looking at measurements, let's say temperature, height, distance, and so forth, those are the continuous type of data, and they are infinite. So it's very important to differentiate between discrete and continuous values, and we are going to see how we can analyze them differently. So you may have discrete or continuous data. And it is important to ask, is your data observed or estimated? So when we are going to deal with the numerical values or numerical data, we will ask, what type of data do we have? Do we have observed data, or we have to estimate our data? Or is your data estimated or observed? Observed data is the data which you can have it, the real data. For instance, if you're looking at the performance of students in the exam, that is observed data. Or if you're looking at the number of students in class, so that's actually observed data. And sometimes we can estimate. For instance, we can estimate how many students are coming to class before they are there, before we observe them. So we will use probability to estimate our data. And when we come to the topic of probability, then we will see how we can make some estimations different from data which is observed. So now we may have we may have discrete data or continuous data, and your data can either be observed or estimated. But it's really important to understand if your data is big data or if your data is a sample that infers the big data. So we'll be talking about the big data or the population, which is the entire distribution of data. And so all entries of interest, that's what we call population or big data. For instance, we look at the people in a country, or we can look at the overall salaries of a company, or any other values in aggregate. A sample data is the section of the population data. And normally, sample data can be randomly selected from the population data. And we can use that sample data to infer the large data. So here we can look at the number of ways of selecting a sample. So we can use simple random sampling. So values will be selected by chance, but also we can select our data or sample data by using systematic sampling or stratified sampling and many other ways. So your data can be small, or we can say sample data or big data. But also we need to ask, is your data time series or cross-sectional? So what is the difference between the two? Cross-sectional data is the data that is collected at the same point of time. Let's say we're looking at your salary, and I can ask you, how much are you earning now? So you can tell me the amount of money that you are earning. That's what we call cross-sectional data, because we are looking at a particular point in time. But time series data is the data which is we can say historical data. We can look at how you've been earning your salary over time. So that's what we call time series data. It's data which has been collected over a period of time, not on the exact time. And in this case, we can look at the monthly data or yearly data and so forth. So you can see it involves a number of time. It is data which is collected over a period of time, but the cross-sectional data is one-time data. It's very important to differentiate between the two, because the analysis of cross-sectional data could be different from the analysis of time series data. So you should know how to separate your data, either cross-sectional or time series data. So the other thing that we need to look for in your data is if your data is normally distributed or it has other distributions. When we talk of the normally distributed data, we are looking at data that is symmetrical. And we'll see how your data can look symmetrical. And so we're going to learn things like standard or normal distribution and standard normal distribution. And also we'll look at data which skews to the left or to the right. And we'll also learn why your data skews to the left or to the right, or when your data, if we put it in a table, looks symmetrical. So that's all with the numerical data. And so it's important to understand those characteristics. As we have said, first of all, you should know that data can either be numerical or non-numerical. And for the numerical data, your data can be discrete or can be continuous, can also be observed or estimated, can be big data or population or a sample. And also your data can be cross-sectional or time series. And your data can be normally distributed or other distributions. So the next is the non-numerical data. As we said, it can be either qualitative or categorical. And we can also look at the characteristics of the non-numerical data. They can be nominal or ordinal. And nominal non-numerical data is data which has no natural ordering of its possible values. For instance, if you are looking at gender, you can start with female or male, which is okay. If you're looking at the number of countries, you don't have to put them in an order. Or if you are talking about the names of the people, may not need to be ordered. But sometimes we may actually need to order them. And if we have to order, for instance, names of the people, so should be ordered on the alphabetical order, then that's what we call ordinal. It is no longer nominal data. So it's important to know when you should, when your data is nominal and when it's ordinal. So for the ordinal is when your data, your non-numerical data, is organized in a certain fashion. For instance, if you're talking about the education levels, so in this case, we have to look at the first degree, second, or the third degree. Also, we normally put our priorities in an order, or we rank. That's about non-numerical data. It can be nominal or ordinal. And also for the non-numerical data, we can try to find if your data is a sample or it is a big data. So I think that's all we learned on Tuesday, the first week of our class meeting. And all I'm going to ask you is to go through this PowerPoint. Try to remind yourself about those characteristics of data, because we'll be talking about them as we move on. Thank you. And we are going to move to the second topic.